In this video, we're going to learn how to find zeros of a polynomial function. Now first, I want to get into a nice definition, is if there is a real number b and a polynomial p of x, the b will be in green, the polynomial will be in red. X minus b is a linear factor of the polynomial. If we know that is true, then that b value is also a zero of the polynomial function. It is a root to the equation p of x is equal to 0, meaning you can set it equal to 0, and each value of b is also an x-intercept of the graph of y equals p of x. So now, why is this important is now, if I can factor a polynomial, it means I can find the zeros, roots, and x-intercepts of that equation, which all play a big part into graphing. So for this next one, we're going to find the zeros of each function and then graph the function. So I've already gone ahead and factored the polynomials for you. We're just going to find the zeros and the x-intercepts. And the way you find zeros and x-intercepts is to take your polynomial and set it equal to 0 and just solve that equation, meaning find the roots of that equation. So in order to find the zeros of this function, I'm just going to set x plus 2 times x minus 1 times x minus 3 equal to 0 and solve. And using the zero product property, I can set any of these factors equal to 0, because if any of the factors equals 0, the whole thing is 0. So I'll get x is equal to negative 2, x is equal to 1, and x is equal to 3. So these are my zeros for the function. So I would say they are negative 2, 1, and 3 are my three zeros. Now, how does that translate to an x-intercept? Well, I just put them as a point. So, nope, not 0. Negative 2, 0. 1, 0. And 3, 0. So these are our 3 points on my graph. So negative 2, 0. 1, 0. And 3, 0. But that doesn't help me form this graph. That's just 3 points along the x-axis. I do need to find other points so I can understand how it may bend through the space. So we're going to find points between the zeros. So we'll start with plugging in, let's say, between negative 2 and 1, we have negative 1. So I'll plug in negative 1, which means that y would equal negative 1 plus 2 times negative 1 minus 1 times negative 1 minus 3, which gives me 1, negative 2, and negative 4. So multiply it all together, that gives me 8. So a point I can use is negative 1 comma 8. So negative 1 all the way up to 8 is 1 point. But now I can also plug in 0 to see what another point could be. So y is equal to 0 plus 2 times 0 minus 1 times 0 minus 3, which gives me 2 times negative 1 times negative 3, which all together gives me a positive 6. So another point I could plug in is 0 comma 6. So 0, 6. And then after that 0, it does go to the point 1, 0, but I can also plug in 2. So you'll see here I'm just picking points in between my zeros, my x-intercepts. So now I'll try out 2. I already know what happens at 1. So we have 2 plus 2 times 2 minus 1 times 2 minus 3, which gives me 4 times 1 times negative 1. So it ends up giving me just negative 4. So another point is 2, negative 4. And now I can kind of see all the points to go through, but to help me really understand exactly how it's going to look, I do want to figure out what my end behavior is for this function. But it's not in standard form, so I need to at least figure out what the leading coefficient is. And the way to very quickly and effectively do that is to look at the leading term of each factor and multiply them together. So what is x times x times x? X cubed. There's my leading term. What is the end behavior that goes along with that? Positive x cubed. Positive means it goes up to the right, but then down to the left. So down and up. So down to the left, up to the right. So I'm going to write that again. As x goes to negative infinity to the left, y should go down, so y approaches negative infinity. And as x goes to positive infinity, y approaches positive infinity as well, because I know it goes up to the right. And again, the way I figure that out one more time is, since it's a positive x cubed, I know it goes up to the right, and since it's an odd power, I know they go in opposite directions. So as I graph this, since this is my first point I can use on the left, I know it goes down to the left. So the way I approach that point is with an arrow down to the left. And I'll go through that point, and the next point I need to go through is all the way up here at negative 1/8. So I have to keep going up. Oop. Being very careful, it's a very steep line. And curving my points to go downwards, to go through my y-intercept I see there. Then that point goes through the x-intercept, which again curves again through that point. We go back up through this x-intercept, and I know it goes up to the right. So this thing will just keep going up and to the right. So my graph looks something like this. Definitely tough to sketch, but you get the idea. And again, it goes down to the left, up to the right. You'll see here I have two turning points. They seem to happen around these points, but maybe not necessarily at the points. It could be somewhere different. But roughly those are the turning points. And I have two of them for a cubic function, x to the third. Let's try this one more time with a different example. So again, I have negative x times x minus 3 times x plus 5. So to find the zeros, I'm going to set my polynomial equal to 0 and find those roots. Which means I'll have negative x equals 0, x minus 3 equals 0, and x plus 5 equals 0. So x equals 0, x equals 3, and x equals negative 5. So my zeros are at negative 5, 0, and 3. I just put them in ascending order, which means that my x-intercepts are at negative 5, 0, 0, 0, and 3, 0. So negative 5, 0, 0, 0, and then 3, 0. Now, I have a lot of points to pick in between, so I'm not going to plug in every single value in between. I'll just pick two between each of the zeros so I can get a good idea where the points would go. And I'll try to go as center of them as possible to hopefully catch where that turning point is. So I'm going to plug in negative 3 to start, because I'll use negative 3 and negative 2. So I'll get starting off with negative of negative 3 times negative 3 minus 3 times negative 3 plus 5, which gives me negative of negative 3 is 3 times negative 6 times 2. So that's going to be 3 times 2 is 6 times negative 6 would be negative 36. So another point I have is at negative 3, negative 36. So negative 3, this is negative 35, so just below that point. That's for negative 36's. Now let's continue. Let's plug in negative 2. So y is equal to negative of negative 2 times negative 2 minus 3 times negative 2 plus 5, which gives me a positive 2 for that negative of negative 2 times negative 5 times negative 2 plus 5, which is 3. So negative 2 times 2 times negative 5 is negative 10 times 3 is negative 30. So I have another point at negative 2, negative 30. And again, you are allowed to also plug in negative 4 and negative 1. I'm just trying to save a little bit of time. So now we're going to the next section. I'm going to plug in 1 and 2 to find these values. So negative of 1, 1 minus 3 times 1 plus 5. So negative of 1 is negative 1 times negative 2 times 6. Give me a total of positive 12. Negative 1 times negative 2 is 2 times 6 is positive 12. So a point at 112. So 112, about right here. Ooh, and I forgot to put in my -2 point, which is at -30. And now we'll plug in 2 to find that value. So y is equal to negative of 2 times 2 minus 3 times 2 plus 5 for -2 times -1 times 7. Which gives me 2 times 7, which is 14. So the point's at 1, 14. Or sorry, 2, 14. So 2, 14, just under 15. And now we're seeing where all the points are. It looks like it's going to look something like this, with it going up to the left and then down to the right. But let's just double check. Leading term, negative x times x would be negative x cubed. So that's negative. So my end behavior will go down to the right, but then up to the left. Again, negative makes it go down to the right. The odd power makes it go in opposite directions. So to write this with my little limit notation, as x goes to negative infinity, y goes to positive infinity. It means up to the left. As x goes towards positive infinity, which means to the right, I can say that my y values go down, so y approaches negative infinity. Again, the little arrow you say approaches for. So knowing this, I know it goes up to the left. So from this point, I know it goes up. It's going to go through that point down, and it has to go through this point next at -3. So it's probably near where the turning point is. Then it goes through the next point at -2. Then it continues upwards. Goes through that point through the origin, which was one of my x-intercepts. And then it goes through both of these points, then back down through that point and down to the right. But I'll stop drawing there. But that's roughly what that polynomial would look like as well. Maybe it would go up and then back down to that point. So maybe the turning point somewhere in between 1 and 2, because it looks a little weird there. But again, these are just sketches. And that is how you find zeros of a polynomial function.